today's meeting?
I don't understand this part.
Yeah, me too.
Oh, my bad. I wasn't really paying attention.
Oh, great. Maybe try using your eyes next time.
I'm sorry. I'm listening to ACDC.
What? You say ACDC?
Yeah.
You are thinking about ACDC experiments, right? So let's move to explain the experiment.
Is looking to the purpose first to understand how to measure current and voltage in series and parallel electrical circuits.
The second one to understand what the difference between series and parallel in electrical circuits.
An electrical circuit is divided into two types: open, when electrical currents does not flow, and closed, when electrical currents can flow.
Direct current or DC flows in one direction, from the positive to the negative terminal, and it is used in series and parallel, as well as in the application of Kirchhoff laws. A variable resistor allows resistance value to be adjusted. A series circuit has a single path for current flow, while a parallel circuit has multiple paths. What if we can reverse things just like this?
Yeah, you're right.
Okay, so let's change in
One,
1, 2, and... Alright, let's take a look to the tools and material.
So, the first material we need is lamp.
The second one is voltmeter.
Next is ammeter.
Next is rheostat.
And next is pliers.
And another materials we need are wires.
And the next one is multimeter.
And for the last tools and materials is power supply.
First experiment is how to measure electric current and voltage in a DC circuit. 1. Set up the circuit based on the given schematic. 2. Turn on the power supply and adjust the voltage if you are measuring current, or the current if you are measuring voltage. 3. Check and write down the readings from the ammeter for current and voltmeter for voltage.
And the second one is procedure for measuring rheostat resistance. The first one, build a series circuit. Second one, turn on the power supply and adjust the current. Third one, set the resistance from the smallest to the largest value. And the last one, observe the change in current and potential difference as the resistance changes.
Procedure for series and parallel circuit. First, build a series circuit based on the following schematic. Second one, observe the brightness of the light when 1, 2, and 3 light bulbs are added. Third one, build a parallel circuit based on the following schematic. And the last one, observe the brightness of the light when 1, 2, and 3 light bulbs are added.
Based on the data collected, we can observe a clear relationship between the brightness of the lamp and the amount of electric current flowing through the circuit. From the data, we can see that the lamp starts to glow dimly when the current is around 0.14 and 0.175 amps. As the current increases to approximately 0.2 amps, there is a visible change in brightness. The lamp becomes a bit more luminous, though it still isn't at full brightness. When the current reaches 0.225 and 0.245 amps, the lamp shines much more brightly. From the graph of voltage potential difference versus current, we can observe a straight line pattern which suggests a linear relationship between the two. In other words, voltage and current increase together at a constant rate. This means that as you increase the voltage, the current flowing through the circuit also increase proportionally.
Next, we can observe a clear relationship between the brightness of the lamp and the amount of voltage through the circuit. When measuring the voltage, the data show that the lamp dim when the voltage is around 0.5 volts and 1 volt. As the voltage increases to 1.5 volts and 2 volts, the lamp gets a bit brighter. Finally, at 2.5 volts, the lamp shines brightly. From the graph of current versus voltage potential difference, we can analyze the relationship between the two variables. The graph displays a straight line trend, indicating that the current increases linearly with the voltage. In other words, current is directly proportional to voltage as one increases. The other increases as well. This linear relationship means that if we double the voltage, the current will also double, assuming the resistance remains constant.
Based on the data collected, it can be observed that resistance has a significant effect on both the electric current and potential difference in a circuit. When the resistance increases, the current flowing through the circuit becomes smaller. This shows that resistance and current are inversely related. On the other hand, resistance is directly proportional to the potential difference. In simple terms, a higher resistance requires a higher voltage to maintain the same current. These experiments match the relationship described by Ohm's law, which is expressed with the formula resistance equals voltage divided by current.
In a series circuit, the more light bulbs are added, the dimmer they become. This is because the current remains the same throughout a series circuit, so the electric current flowing through the first bulb also flows through the next ones. As a result, the current distributed to each bulb is small, causing the bulbs to glow dimly. Meanwhile, in a parallel circuit, adding more lamps doesn't really affect how bright each lamp shines. This happens because in a parallel step, the electric current that flows through each lamp remains the same. This is in line with Kirchhoff's current law, which states that the total current entering a junction is equal to the total current leaving that junction. So, even two more branches are added to the circuit, each lamp still gets the same amount of current, which is why their brightness stays consistent.
Guys, that is all done. So the experiment is about the current is measured using an ammeter connected in series.
And while the voltage measured using a voltmeter connected in parallel due to the natural circuit and parallel circuit.
Also, Ohm's voltage equals current times resistance was proven, showing that resistance is directly proportional to voltage and inversely proportional to current. So, now we've got it. Wait, why did it suddenly get dark?
Oh, missing it one.
Is this a play card? No, it's not. The switch is still on, but the light's still off. Maybe the bulb is broken? Could be, but hey, do you know this kind of situation is an example for electricity circuits? Why? How come? Well, when we talk about electricity, especially DC or direct current, lamp is one of the most common examples.
Yeah, you are right. A simple DC circuit usually using a power source like battery, wires, and a lamp.
Oh, so in that case, the lamp is the load? Exactly. In a DC circuit, electricity flows in one direction. If any part is broken, the circuit doesn't work, and the lamp goes out. And even though if this room uses AC power from the outlet, the same principles applies. You need a complete circuit for current to flow and for the lamp to light up.
So, lamp can be a part of either or DC and AC circuit depending on the source.
Yeah, exactly. But for basic electronics like battery power light or flashlight, it's usually DC. Cool. Still, can we fix the light now? I'm kinda scared of the dark.
Hahaha. Alright, let's bring some DC powers and let's grab the flashlight first.
Hold on. You said AC/DC? That's kind of electricity?
Wait, you mean the electricity? No, I mean this.